Algebra 2, Chapter 10.2, exercises 12 through 21. This extends from our previous video lesson, which includes problems 1 through 11. And what we're doing now is multiplying and dividing polynomial expressions. And here, starting with problem 12, it says find the quotients and the excluded values. So we have a division problem here, and the first thing I'll remind you of is that when you're dividing by a fraction, is the same as multiplying by its reciprocal. Okay, so what that means is when we divide this rational expression 8x plus 32 over x squared plus 8x plus 16 by x squared minus 6x over x squared minus 2x minus 24, I'm going to take this second fraction here and turn it upside down and multiply. And the first thing I'm going to look at is the excluded values of the expressions here. And to do that, we have to consider the denominator of the first rational expression, the denominator of the second rational expression, but one more thing, we have to consider the numerator of the second rational expression. Why is that? Because when we use the reciprocal or turn this one upside down, this numerator is going to become the denominator, and we cannot divide by 0. So for each of these polynomials encircled, we have to find the excluded values by setting them not equal to 0. So I'm going to work over to the right here and take this first denominator. We'll put x squared plus 8x plus 16 is not equal to 0. And factoring this out, we have 20x plus 4, x plus 4 is not equal to 0. And so, therefore, we know that x cannot equal -4. So that's one of our excluded values. And next, this denominator of the second rational expression, x squared minus 2x minus 24, this cannot be equal to 0. And factoring out this quadratic trinomial, we have the factors of x squared are x and x. And we want two numbers that multiply together with -24, but when added together with -2. And what numbers would those be? I'm thinking 6 and 4, right? And then 6 is -2x, so we're going to have 20x minus 6, 20x plus 4. Is that going to be right? Yes. So we know that x cannot equal 6, nor can x equal -4. So we have a couple other excluded values here. And then finally, we have the numerator of the second expression, which is going to be the denominator of that second expression when we take its reciprocal. We also know that x squared minus 6x cannot equal 0. And factoring out x, we have x times 20x minus 6 cannot equal 0. So now we know also that x cannot equal 0. So we have 4 excluded values here, and we've already taken care of the x and 6. So now we're going to go ahead and rewrite and simplify, and this shouldn't be too bad. So first of all, we're going to rewrite this whole division problem here. We have the numerator. Originally we had 8x plus 32. Well, our common factor here is going to be 8. So 8 times quantity x plus 4. And then we're going to have in the denominator here, 20x plus 4, x plus 4. And that's one advantage of doing the excluded values first, because we can rewrite these expressions in factored form. So now we're taking the reciprocal of the second rational expression, which is going to be, as we worked here earlier, 20x minus 6 times 20x plus 4. And then we take the numerator of the second expression, which is going to be the denominator of when we turn the thing upside down or take its reciprocal. We have x times quantity x minus 6. So now we can just go about canceling things. We have x plus 4 over x plus 4, they cancel. X minus 6 over x minus 6, and x plus 4 over x plus 4. And what we have left here is 8 over x. And 8 over x is our simplified answer with all these exclusions. And the only one obvious from this final answer is x cannot equal 0. We already determined that earlier. Okay. Let's go on to the next modular problem, which is 15. Here we have this next set, 14, 15, 16, 17 set. Let p of x equals 1 over x plus 1 and q of x equals 1 over x minus 1. Perform the operation and show that it results in another rational expression. So here I rewrote p of x and q of x, and we want to find p of x minus q of x. So we're going to take 1 over x plus 1 minus 1 over x minus 1. Well, our excluded values since we cannot divide by 0, are going to be x cannot equal plus or minus 1. And so that's going to be our excluded values here. Pretty straightforward. Okay, now what do we do to get a common denominator? Well, our common denominator is going to be the product of 20x plus 1 and x minus 1. So let's go work that out. We have 1 over, we have 20x plus 1, x minus 1. And what do we have to multiply by? This x plus 1, x minus 1. So x minus 1 will go up here. We subtract 1 over x minus 1. And what do we have to multiply by x minus 1 to get our common denominator, which will be x plus 1, or x plus 1. So what we have distributing here and working below, we have 1 times x minus 1, that's going to be x minus 1. And we have minus 1 times x plus 1, minus x plus 1. I keep this in parentheses. And right below here, we have 20x plus 1. That's 20x minus 1. And x minus x will cancel. And then we have negative 1 minus 1. So our answer here is going to be negative 2 over 20x plus 1. That's 20x minus 1. So there we have it. And this is a rational expression. We have a, so that'll be it. Okay, next 17. P of x divided by q of x. And here we have both of our expressions here. Again, what are excluded values? Same as before, x cannot equal plus or minus 1. So now we're going to take a quotient of these two expressions. We're going to take one divided by the other one. So we're going to have p of x, which is 1 over x plus 1. And we're going to divide by, division, divide by 1 over x minus 1. And to make a multiplication out problem out of this, we're going to take this second expression and take its reciprocal, which is going to be x minus 1 over 1. And when we multiply these together, we are simply left with the rational expression x minus 1 over x plus 1. Okay. Okay. Let's go on here to next on our problem, which is 19. Juliana is designing a circular track that will consist of 3 concentric rings. So circular is a key word, and rings also concentric. Concentric means, of course, centered in the same location. The radius of the middle ring is 6 meters greater than that of the inner ring and 6 meters less than that of the outer ring. Find expression for the ratio length of the outer ring, the length of the middle ring, and another for the ratio length of the outer ring, the length of the middle inner ring. The radius of the inner ring is set at 90 meters. How many times longer is the outer ring than the middle ring and the inner ring? Okay, that's a lot of verbiage. Basically, what we're looking at here is the circumference of a circle, and the circumference is equal to 2 pi times the radius. So for the inner ring, what is our expression going to be? Well, it's going to be 90 2 pi r, which is 90. So let's just call the expression r, first of all, 2 pi r. Because then we have the condition later. The middle ring, we have the radius of the middle ring is 6 meters greater than that of the inner ring. So we're going to have 2 pi times quantity r plus 6. And the outer ring is going to be 2 pi times the inner radius plus another 6 is going to be plus 12. So these would be our expressions for the ratio of the length. Let's see. Okay, the ratio. So we will say the ratio of the length of outer ring. So our outer to inner is going to be equal to, well, it says middle first. I'm going to do the middle first, then the inner. So we're going to have 2 pi, and we're going to have r plus 12. Well, that's going to be 90 plus 12, and that's going to be equal to 2 pi times 102. And that and that. And our middle is going to be 2 pi 90 plus 6, or 2 pi times 96. That's a little more legible. And so what we have here is 102 divided by 96, which simplifying, I'm just gonna work below here. We're gonna have 102 divided by 96. That's going to be 51 divided by 48, or we divide that by 3. Let's see, that's going to be 17. 17 divided by 16. So 17/16 is our ratio here. That will be our outer to middle, and now we're going to have our outer to inner. And that's going to be 2 pi, same as above, times 102 over 2 pi times 90. And 2 pi over 2 pi cancel. So we're going to have 51 over 45, which simplifies to 17/15. That's going to be our ratio of our outer to inner. And then we can decimalize these also. We're going to next go to problem 21, which is the last one we're going to look at here. And this is a focus on higher order thinking. Explain the error. Maria finds an expression equivalent to, and she gives the expression here. Her work is shown. Find and correct Maria's mistake. Well, in what we have to do when we divide by a fraction, here you have a division by a fraction, we have to multiply by a reciprocal. And here, let's make sure everything was right. We factored out this x squared minus 4x minus 45. Is that going to be that? It looks like that's properly factored. That looks good. Next, we have this 3x minus 15, which factors out to be 3 times quantity x minus 5. That looks good. And we're dividing by this 6 I'm just going to work this out here. 6 times x squared minus 25. Well, that's going to be 6 times x plus 5, x minus 5, x minus 5. That checks out. So that's good. And this last one here, we have x squared minus 5x will factor out to x times 20x minus 3. Okay, so next, divided by a fraction, the same as multiplying by reciprocal. So we're going to have to take this 6. We keep x minus 9 and x plus 5 in the numerator here, and we keep 3 and x minus 3 down here in denominators. We checked out all those. But then we're going to find the reciprocal, or turn the second expression upside down. So 6, this 6 should go down here. Well, I don't see any 6 down here at all. I should see 6 and x minus 5 and x plus 5, and I should see the x and x minus 5 up here. So it seems like the mistake is going to be here. So I'm going to go ahead and rewrite and take this part right here. It says find and correct Maria's mistake. So I'm going to correct it by taking this part right here and rewriting it as x minus 9, x plus 5 over 3 times x minus 5. And now I'm going to turn this second one upside down and write down below 6 x plus 5 x minus 5, and then put up here x times 20x minus 5. And so now we have a proper rewriting here, which is going to give us in the denominator. Well, I'll just cross stuff out here. So here we go. That crosses out x plus 5 over x plus 5. So left in the numerator, you have x times x minus 9 over 18 is going to x minus 5, which is different than the original here. So we found actually just the wrong rewriting and combination of this division problem being changed into a multiplication problem. Yeah, that's what they got. So anyway, this is our real answer. I hope this has been helpful to you. Good luck, and thanks for viewing.